3, 2, 1.
On the 20th of February 1962, America's first manned spacecraft, Friendship 7, carrying Lieutenant Colonel John Glenn, successfully orbited the globe 3 times and was recovered safely in the Pacific Ocean. Aboard the spacecraft with Colonel Glenn was a single camera whose efficient mechanism succeeded in recording color photographs of the surface of the Earth. Giving ample proof of its superb technical quality, this camera met every demand made upon it by the unknown conditions of outer space and succeeded in recording invaluable photographic data. This camera, the only still camera carried by the spacecraft, was made in Japan. Its name, Minolta Hi-Matic. 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 Japan, a new Japan. Japan, which has risen from the chaos of the post-war years to become a new nation of peace and culture. It is this lovely land of Japan that has become the birthplace of a new camera for the space age. About 6 hours by express train from Tokyo is the city of Osaka, center of Japan's industrial endeavors. Here in Osaka is the head office of the Minolta Camera.
I am Kazou Tashima, founder, president of Minolta Camera Company, Japan. Before we view the movie film, which shows something about how the Minolta operations work, I'd like to say a few words about the philosophy we have tried to instill into the Minolta company. Most manufacturing firms have a concept or principal idea which they follow strictly in the production of their goods. The concept at Minolta is to make every effort to produce what is original and unique. In the modern 50 basic cameras Minolta has introduced, all of them have contained something unique in mechanism, design, or construction. Here, for example, is one of the very first Minolta cameras, made some 35 years ago. It is old-fashioned by today's standards, but at the time it was introduced, it was considered quite an innovation. Our most notable example is the Minolta Hi-Matic, the camera which was selected by the United States Space Agency and used by Lieutenant Colonel John Glenn while orbiting Earth in his spacecraft Friendship 7. Another camera we are particularly proud of is the recent Minolta SR7. This is the world's first still camera with a built-in CDS light mirror. This film we are about to see represents a part of the Minolta story, the manufacture of cameras. I hope you find it interesting, and in the future, look to Minolta for your cameras and photographic needs. Thank you.
To stand in the forefront of the camera makers of the world, new ideas must constantly be developed and convert it to reality. At the head office of Minolta Camera, expert designers are in conference every day to discuss new models and their performance. The various ideas which come out of the conference room go to the designing department to be put into concrete form and drafted into blueprints. On the basis of these blueprints, prototypes are made. These prototypes are then given careful and detailed study by each of the specialized departments. These carefully thought-out plans, coupled with the ceaseless efforts of the technical staff, form the motive power for the manufacture of the Minolta camera. Minolta has plants, business offices and service stations throughout Japan, and this huge network manufacturer sells and services Minolta's products. At its 4 factories and 1 laboratory, Minolta has installed the most modern of camera manufacturing equipment. Here, the various parts for the Minolta camera, including Minolta's pride, the green Rockwell lens, are manufactured and assembled with unparalleled precision. Minolta carries out a completely integrated manufacturing process from the melting of optical glass to the completion of the finished product. Minolta manufactures quality products under thorough quality control. The temperature inside the crucible taken from the electric furnace is as high as 1000 degrees centigrade. The glass is melted red. To melt rare element glass, a special platinum crucible with a high degree of purity is used. Impure portions of the glass mass are removed and softened in the electric furnace. In this way, a glass block of uniform quality is produced. This is the material from which the lens will be made. At this point, the glass undergoes a rigid quality test. Portions which fail to pass the test are checked and then removed by a diamond cutting machine. Here, the glass is cut to the size of a single lens, measured, and placed in the electric furnace. The softened glass is then pressed into the shape of a lens. The pressed lens again goes through an annealing process and is gradually cooled. This process is called precision annealing and is carried out with the utmost care. The Minolta SR7 contains approximately 1200 metal parts, totaling 700 separate items. From the smallest screw to the die-cast body, the manufacture of each part requires a high degree of precision. These machines are among the most exacting of precision machine tools. To permit them to operate at maximum efficiency, the working areas where they are installed are kept at a constant temperature of 20 degrees centigrade. Here, jigs and metal forms are automatically made for the manufacture of camera parts. The automatic machine plant. All metal parts are manufactured by automatic precision machine tools. The metal work plant. Manufactured parts are always projected and enlarged from 20 to 30 times to permit minute examination of each part so that necessary corrections may be made. The metal finishing plant. Here the plating and painting of metal parts is done. Satin finishing by liquid honing. Glossy nickel plating. Chrome plating. Almite finishing. Painting. Infrared drying. At the lens manufacturing plant, meanwhile, the material for the lens is about to undergo its finishing process. Rough grinding. Polishing. At this plant, the lens becomes transparent for the first time. To determine whether the polishing of the lens has been done correctly, the Newton standard is used, and a check is made of lens precision to a degree of 1/10,000th of a millimeter by the striped patterns created by light interference. The center line of the lens is first determined. Then the lens is polished and finished in accordance with this center line. Lens coating. Coating of the lens by an epochal method is the final process in the finishing of the lens. The Rocol green lens, which has become so popular and in which Minolta has taken particular pride, also undergoes this process. lens assembly. Assembling light meters. And now the camera is entering its final stage of manufacture. Minolta points with pride to its world-standard production system featuring constant room temperature and air conditioning so necessary for precision manufacture, and its smooth-flowing conveyor system which enables assembly line production. This production system, coupled with the industry of the Japanese workers and the youthful energy of those who handle the manufacture of each important part, enables Minolta to market products of the highest quality. Inspection of the shutter. Adjustment of the range finder. Adjustment of the light meter. Assembly of the Minolta Zoom 8. The Minolta Hi-Matic. The greatest importance is placed on the performance test of finished products. Partial tests are given to the bodies and lenses at each stage of their manufacture. Imperfect parts are removed at each respective stage. Finished cameras are again placed on testing machines and measuring devices. Only those which have passed these many tests are set out to the world markets as Minolta cameras. Japan's first post-war domestically constructed planetarium was also the result of Minolta's outstanding optical techniques. Minolta, the camera for the space age. Its outstanding performance has received the plaudits of people the world over. And each year, exports of Minolta cameras are increasing by leaps and bounds. The Minolta camera now stands shoulder to shoulder with the best in the world. The camera for the space age. Minolta, Minolta, Minolta.